Okay, so when you hear cybersecurity, what comes to mind? Probably firewalls, right? Viruses? Well, today we're diving into a totally new battleground, the mind of an AI itself.
So, what do you think is an AI's biggest weakness? Is it how fast it can think or how much data it has? Nope. The real vulnerability is, well, it's something way more basic. It's actually hiding in plain sight.
Just get a load of this quote. A single malicious prompt can turn a powerful AI into a security risk. I mean, let that sink in for a second. We're talking about the big guys, right? The large language models, the LLMs, that power things like ChatGPT. And what this means is that one single cleverly written sentence can basically weaponize one of the most powerful technologies we've ever created.
And that really gets to the heart of the problem here, what we're calling AI's hidden vulnerability. We're about to see how the AI's greatest strength, its amazing ability to understand what we're saying and follow our instructions, is also, kind of ironically, its biggest flaw.
So if you're a developer building one of these awesome AI apps, you know what your biggest problem is? It's not making it faster or smarter. Nope. The number one challenge, the thing that keeps them up at night, is prompt security. It's all about protecting the instructions that make the AI tick. And believe me, the stakes are incredibly high. A successful attack, what they call a bad prompt, it's not just some little bug. It can lead to absolute disasters. We're talking about sensitive company data getting leaked all over the internet, whole services just shutting down, or even worse, the AI getting tricked into doing something really harmful that it was never supposed to do. Okay, so to build a good defense, you've got to learn to think like the offense, right? So let's crack open the hacker's playbook and take a look inside the mind of the red team. These are the good guys, the security pros who pretend to be attackers to find all the weak spots. And what's really fascinating is that these attacks, they're not about writing crazy complex code. They're more like social engineering for a machine. You've got role-playing, where you basically convince the AI it's an actor in a play and doesn't have to follow its rules. Then there's goal hijacking, where you just sneak in a new instruction to totally change its mission. And then you have the sneakiest one of all, indirect injection. So let's zoom in on that role-playing attack. Probably the most famous example is this thing called DAN, which stands for Do Anything Now. The way it works is an attacker tells the AI, hey, you're not you anymore, you are Dan. And Dan is a character who has no rules, no safety filters, no ethical guidelines. And just like that, poof, your helpful AI assistant turns into a total renegade. But if you were to talk about sneaky, let's talk about indirect prompt injection. This is the real Trojan horse of AI security. See, with this one, the attacker isn't talking to the AI directly. Instead, they hide the malicious command inside something else, like an email or a website or some document. Then when you ask the AI to, say, summarize this web page for me, it reads the page, finds the hidden command, and bam, the attack is launched from the inside out.
All right, so that's how the red team attacks. The big question is, how do we fight back? Well, that brings us to the Defender's Fortress. Let's see how the blue team, the good guys on defense, build their walls.
The most important thing to get is that there's no single magic solution here. The best defense isn't just building one giant wall, because walls can be broken. No, it's about creating a deep, multi-layered system. We're talking about sanitizing inputs, filtering outputs, and weaving security right into the fabric of the AI's design. So let's walk a prompt through this fortress, step by step. Okay, first up, input sanitation. Before a prompt even gets to the AI, it gets scrubbed clean, checked for anything malicious. Then step 2, secure processing. The system creates really clear boundaries, almost like a digital fence, to keep the user's input totally separate from the AI's core instructions. And finally, step 3, output filtering. After the AI creates a response, it gets scanned one last time to make sure it's not leaking anything sensitive or saying something it shouldn't. You see, every single stage has a guard. And the difference is pretty stark, right? An unprotected system, that's like a wide open highway straight from the user to the AI's brain. But a protected system, that's more like a fortress with heavily guarded gates. You've got security filters acting as gatekeepers, checking everything that comes in and everything that goes out. Now, for the real high security stuff, you've got something called a dual LLM architecture. This is a really clever setup. You have two AIs. One is the worker, it does the actual task you ask for, but then you have a second AI, the inspector, and its only job is to watch the worker. It checks every single input and output for safety. It's kind of like having a writer and a very, very strict editor, where the editor's job is just to make sure nothing dangerous gets published. So, what's the big picture here? Well, It's an ongoing cyber battle. It's a game of cat and mouse that honestly never really ends. All right, so let's recap the big takeaways from all this. First, the AI's amazing ability to understand our language, that's both its superpower and its Achilles heel. Second, these attacks are less about code and more about clever social engineering. Third, when it comes to defense, one fence is never enough. You need a fortress with multiple layers. And finally, you gotta remember this is a constant race. Red teams find a new trick, blue teams build a new defense, and it just keeps going. And all of this leaves us with a really big question for the future, one we all need to think about. As these AIs get smarter and become part of everything we do, how do we make sure they stay safe? How do we build the right guardrails for this incredible new technology?